Ask My Instructor 4.1.33. We're given the function f of x equals sine squared x on the closed interval from 0 to pi. And we're asked to find critical points and the absolute extreme values. Then we're asked to use a graphing utility to confirm our results. As stated, the interval is a closed interval from 0 to pi. And you might have noticed f of x being sine squared x is a continuous function. So by the extreme value theorem, our function will have an absolute max and an absolute min on this closed interval. And the procedure for finding the absolute max and the absolute min is given here. And our first step in the procedure will be to locate critical points. Well, what is a critical point? A critical point is a place where either the derivative equals 0 or where the derivative does not exist. So we're going to look at our function and find its derivative. So our function is sine squared x, which I rewrite as sine x quantity squared. And then it's easier to take the derivative if I write it this way. So using the chain rule, I bring down the 2, and then I have sine x to the 1 power times cosine x. After I do that, I just do a little cleanup. Now notice sine x is defined everywhere, and cosine x is defined everywhere. So our function is differentiable everywhere because the derivative is just 2 times sine x cosine x, and so it's just the product of two functions that exist everywhere. So the function is differentiable everywhere. And so in order to find critical points, we just find where f prime equals 0. So where is f prime equal to 0? If twice of sine x cosine x equals 0, then either cosine x has to be 0 or sine x has to be 0. So let's look at cosine x first. Where is cosine x equal to 0? Looking at my unit circle, I can see that cosine x is equal to 0 at the top of my unit circle and at the bottom of my unit circle. Now my closed interval is just from 0 to pi, so only pi over 2 is in my interval. What about sine x? Where is sine x equal to 0? Well, sine x is equal to 0 on the far left and far right of my unit circle. However, keep in mind that endpoints cannot be critical points. A critical point of a function must be on the interior of the interval that you've been given. And our interval is the closed interval from 0 to pi. So both of our points, 0 and pi, are on the endpoints and therefore are not critical. So we only have one critical point, and that occurs at pi over 2. Now that we have found our critical point, we next evaluate the function at any critical points we have. We only have one. So we need to evaluate our function at our critical point pi over 2. So now our function is f of x of sine x quantity squared. So what is sine of pi over 2? Well, that's just equal to 1. And so our function, now not the derivative, but the function itself, what is its value? The function has a value of 1 at pi over 2. And so our critical point, pi over 2, the function has a value of 1 at that location. How about evaluating the function at the endpoints? Well, sine of 0 equals 0, and so f of 0 equals 0. And so f of 0 equals 0, and our left endpoint has a height of 1. Okay, how about our other endpoint, pi? Well, sine of pi equals 0, and so f of pi equals 0. And so our other endpoint also has a height of 0. Our last step in this procedure is to choose the largest and smallest values of the function. Well, that's not too difficult for me. The min occurs at the left endpoint and the right endpoint. The maximum occurs at the critical point, pi over 2. Now, the only other thing we need to do is to use a graphing utility to confirm our results. I prefer to use Wolfram Alpha. In this case, though, the function is fairly straightforward, and you may find that you can do it without using any graphing utility at all. Just keep in mind what sine x looks like from 0 to pi. If we're to square each value, then all you get is a slightly sharper curve. However, if you want to use technology, you can either use Wolfram Alpha or your graphing calculator. And however you do it, then you just look at your choices in my math lab and choose the one that you think best fits your graph. And on the graph, you can see our two endpoints are the minimum, absolute min, and our critical point, pi over 2, gave us our absolute max. Take care and have a good day.